The Microsoft Assembler is freely available and can be downloaded online, but it's not a standalone assembler. To be able to install it, you must have the Microsoft C++ compiler already installed. Now you can download the assembler and the required compiler by going to this website, and there are alternatives. The A86 assembler is a commercially available assembler with a debugger and can be purchased and downloaded at this website. Also, there is a freely available assembler called MASM 32, which is compatible with the Microsoft assembler, but it doesn't bother with the 16-bit models. It only assembles 32-bit code, which is fine if you run Windows rather than DOS. You can find out more about it and download a copy of it at this website. It comes with all the libraries and macros and such that you'll need to program. The syntax of the MASM assembly language is similar to the NASM assembler of this course. The mnemonics are the same, but there are some differences. It's not case sensitive. This is a Windows characteristic and is inherited from DOS. The big letters and little letters are all exactly alike. Some memory references require square brackets, and some do not. For example, this statement copies a value from memory into a register. To get the address of the location, you need to precede the variable name with the keyword offset to tell the assembler you want the address, not its contents. Along with variable names, the type of each variable is stored and used by the assembler. For example, no size need be specified for this instruction. If it is a word size number 2 will be stored in it. The names of the floating point registers work the same way, but they include parentheses around the numbers. It looks like some kind of expression, but it's not. It's just the way the names are written. To declare a 10-byte number, the internal form of the floating point values, the keyword is tbyte instead of tword. The question mark character specifies that a block of memory not contain an initial value. The NASM syntax for a block of 64 bytes of uninitialized data looks like this. As you know, the MASM assembly uses the regular declarative pseudo-op, but with the dupe keyword followed by a question mark. In addition to the other differences, the preprocessor operates differently. The form of macros is very different, and the preprocessor directive works differently.